So hey guys, my name is Aman Maleva, bearing the USN 1VE21IS003, and today my topic is about comprehensive analysis of statement testing in software testing. Introduction. In software testing, statement testing is a crucial technique for ensuring code reliability. This presentation provides a comprehensive analysis of statement testing method, including its benefits and challenges. In software testing, we will learn about the purpose. The purpose is to identify the errors, gaps, and missing requirements in contrast to an actual requirement. The key aspects are also going to be about verifications. We are building the product, right? Validations. Are we building the product, right? Scope ranges from the unit testing of individual components of system and acceptance testing for entire application. Okay, so then after that comes the next topic, which is about understanding what is statement testing. So, statement testing aims to evaluate every individual statement in the code to identify potential defects. It involves executing code paths to verify the correctness of each statement. Understanding this technique is essential for effective testing strategies. Now, when we're speaking about the statement testing, we have to keep some things in mind, and those things are the purpose to ensure that every executable statement in the program has been exercised at least once during the testing. The key concept here is it is a white box testing technique, meaning it requires knowledge of the internal structure of the code. Granularity operates at every fine level of detail, examining individual lines of code. So this is how software testing is built. It is basically built on identifying errors on a line-to-line basis. We are supposed to look into each and every line of the code to identify what is the mistake and how can we solve the mistake. Going on to the next thing, which is basically there are several types of system coverages, including basic block, line, and path coverage. Each type offers unique insights into the code's behavior and test effectiveness. Understanding these types is crucial throughout the testing. Then we will speak about uh, the other topic, which is the objectives of testing. Comprehensive coverage ensures every line of the code is executed at least once. Error detection identifies syntax errors and logical errors and all the other runtime errors which is possible. Then we have dead code identification, which discovers unreachable and unused code segments. Requirement verifications confirms that code implements all specific requirements, and the code quality improvement, which enhances the overall code quality maintainability and everything based on the code's quality. Now, when we're speaking about the advantages of the statement testing, is that statement testing provides granular insights into the code's behavior, enabling the detection of specific defects. It also facilitates measurable coverages metrics, aids in risk assessments and quality improvements. Despite its benefits, statement testing poses challenges such as incomplete coverage, complex control structures, and dynamic behavior. Overcoming these challenges is crucial for effective testing. Now, testing techniques. So there are various ways in which we can get the statement testing started, and few of the most essential and the most used ways are various include which are boundary value analysis, equivalence partition, and decision tables are employed for effective testing statement testing. Understanding and applying these techniques in a vital for thorough testing. Now, when we're speaking about the testings, What we basically mean here is how we are going to cover n number of lines and have an automatic and autonomous way of testing each and every line. So basically, there is a formula for that. So here I'm going to show you guys the formula. The formula is total, the formula is the number of executed statement by total statement, total executable statement by 100. So, and for an example, if we take, there are 100 executed statements in which 80 are covered. So basically, there's an 80% coverage through which we can understand only 80% of the code is being completed, completely executed. So now our goal is always to achieve 100% statement coverage. Through this, even though it is not always an ideal case, but then we try to keep the error to the most minimum as possible. In this, we get to know that if there is 100%, if there is 0% coverage, it is not, the code is not acceptable. If it is 50%, it is minimal. It's just borderline passing. If it is 80%, it is good. But when it is 100%, that is what everyone requires. It's an ideal, but often challenging. The code complexity is always really hard to achieve when it's 100%. Best practices for statement testing is implementing automation, continuous integration, and code reviews for essential best practices. Best practices for successful statement testing. The practices ensure consistency and efficiency in the testing process. Measuring statements, again, I've covered it before, but then again, go through the slides. Metrics such as statement coverages, branch coverage, and path coverage are often used to measure the effectiveness of the statement testing. These metrics provide insights for the thoroughness of the testing process. Case studies on statement testing is basically real-world studies showcasing the impact of statement testing on the software quality and reliability analysis. These cases provide valuable insights into the practical application of the statement testing. Now, when we're speaking about case studies on statement testing, we'll have to even go to the statement testing processes. So, while we're speaking about code analysis, we should examine the source code and identify all the executable statement. Test cases design create test cases to execute each statement at least once. Run the design state test cases coverage measurement, calculate the statement coverage achieved, gap analysis, identify the statement that were not executed, additional testing, design and execute more test cases to cover gap, and then report, document all the testing which is required, which we call it even as this description, where we describe what are the errors we find and what because of what can the errors be solved also sometimes, and because of what the errors can be caused also. So the various ways in which we can solve and we can even get to know what errors are we facing by using the scale statement testing processes. Now, when we're speaking about the future trends of statement testing, emerging trends such as machine learning, AI-based testing tools, and mutation testing are shaping the future of statement testing. Understanding these trends is crucial for staying ahead in software testing. When we look at the recommendations for statement testings, we have recommendations like enhancing statement testing effectiveness and adapting to evolving technologies. These recommendations aim to improve the reliability and quality of the software. Conclusion. In conclusion, I would just like to conclude it by saying that statement testing plays a very pivotal role in ensuring code reliability and quality. Understanding its technique challenges the best practices in essential for software testing, and it continues to for its improvements.